So here are some of the main questions that I want to try to address. And so where is the Arctic? What countries are part of the Arctic? How big is it? What does it look like? And does anyone live there? And this happens to be a scientist walking through it, but no, this is actually Matt Schupa, somebody else in our group. Where is the Arctic? Well, Arctic obviously is surrounding the North Pole being right here in the middle of this picture. And there's a lot of different definitions of what the Arctic is. One definition that some people use is it's everything north of the Arctic Circle, which is this dotted line. And so if we take that definition, you see that the center of the Arctic is basically an ocean. It is an ocean. And it's mostly sea ice covered, at least for much of the year. And there is some land around the periphery of this Arctic Ocean, and there are some settlements on that land also. So, those settlements include some, what you probably call cities, mostly villages, and also some research stations, military stations, those kind of things. Oh, I also want to mention that there is what's called an Arctic Council, which is an intergovernmental forum, and the members are Canada, Denmark, because they control Greenland, Finland, Iceland, Norway, Russia, Sweden, and the United States. And there's also some observers to this Arctic Council, and that's in the light blue here. China and India, interestingly, are part of observers to that. All the European countries are observers, and also Japan. How big is it? Well, the United States basically fits within the Arctic Ocean. So that gives you an idea. I want to point out that with the exception of one Russian ice drifting station that's typically there, and also some buoys, ice buoys people put out, there are no observations in the entire Arctic Ocean. No atmospheric soundings, anything like that. We're relying on satellites, basically, over the entire Arctic Ocean. The land sites, however, we do have some measurements, some balloon measurements, for instance, in the atmosphere. And I'll get to that in a bit. So what does it look like? Well, the sea ice, of course, is a very important part of the Arctic, as I mentioned. And so it has an annual cycle. In March, which is kind of its largest extent, the entire Arctic Ocean pretty much is filled by sea ice, with the exception of the Norwegian Sea and the Barents Sea here, because of the Gulf Stream affecting that region. But the sea ice actually extends out through the Bering Strait and along the east coast of Asia, and also along the coast of Labrador, and of course Hudson Bay, an entire Canadian archipelago. That's the maximum extent each year. In September each year is melted way back. And now, in the last decade or so, we're down to having open water within the Arctic Ocean along the coastlines in September. But I will get back to the September sea ice extent in a little bit here, because that's what people are usually measuring. So what's it look like there? Well, this is a picture I took flying in a small aircraft over the Beaufort sea ice. Actually happens to be in the 1990s, so it was a little bit before the large melt-offs that have occurred recently. But nevertheless, it shows the idea of what it looks like. Sea ice is up to maybe 10 feet thick, but a little bit thinner nowadays. I'll get to that in a little bit too. And it's basically flat with some ridges that might be 8 to 15 feet high above the sea ice itself. To get a scale here, here's a cluster of probably 25 or 30 tents on the sea ice. That's what we just took off from in this aircraft. So we landed and took off from the sea ice. And below the sea ice here, so it's 7 to 10 feet of ice. Then below the sea ice is about 4,000 meters of water down to the bottom of the Arctic Ocean. So this sea ice is a very thin layer, but it's very important. It's often broken up by what's called leads. These can extend for very long distances, hundreds of miles or hundreds of kilometers. Their width can be just a few tens of meters across, or up to maybe a couple kilometers in width. They may last for a few hours or even a couple of weeks. And they're basically separating two different ice flows, and the flows may come together or open up. And that's part of ice dynamics. Cryospheric people study ice dynamics quite a bit and try to understand what causes these leads and both close and to open. During the summer, the individual flows are more easily distinguishable because they're often surrounded by some leads, a little bit of open water, rather than being frozen together like they are typically in late winter. And they can have different sizes. This flow is roughly around 5 miles in diameter, but that gives you an idea that there's a lot of range in the sizes of the ice flows. And they're moving around, and especially when they start getting open water around them, then they're almost independent. But there's, of course, enough of them here, the density is enough, so they do impact each other as well. Over the land areas, on the Canadian side, the Canadian archipelago, Greenland, so maybe I should say the Western Hemisphere, until you get to Alaska, it's typically fairly rugged. And there's typically ice caps on these mountains that are a couple thousand meters high, and with glaciers coming off of them. This happens to be on Axel Heiberg Island in the Canadian archipelago. This is Ellesmere Island, which is next door to Axel Heiberg Island, where Eureka is located. The flux tower is right there. So it's a beautiful spot, actually. But the point is here that there's a lot of complex terrain. There's tundra, but in this case, complex terrain tundra. You can see some grasses, and you can get an idea here that this area looks a lot like the tundra up in the mountains here. It's very similar when you get above tree line. One thing that's much different than down at these lower latitudes is that you have darkness. This is a photograph I took in late February at Alert, also on Ellesmere Island. And this was noon, looking south. Sun hasn't risen. And so this is the lightest it had been for 4 months. About a week earlier, it didn't even get light at all. It was totally dark and had been dark for at least 3 months before. And so there's a large period of darkness. In the spring and the fall, there's the diurnal cycle, the typical diurnal cycle you see. But then in the summer, it's all light pretty much. There is some changes in solar radiation unless you're right at the North Pole. So there's some diurnal cycle, but it doesn't go down. It doesn't ever not have any solar radiation. And, of course, temperatures can be quite cold. And Alert tends to have a fair bit of snow, as in contrast to some other places like Eureka, which typically does not. Other places, there's much more tundra, much more vegetation. This is Tixie. Some terrain there also, but it's much more lush and grassy. And this is the tundra outside of Barrow. And a lot of muskegs are these little lakes. It's very marshy and very difficult to walk through. And so it kind of gives you an idea of what some of these areas look like. Are there people living there? Yes. There's some small towns or villages. Ny-Ålesund on Svalbard, population 35. Resolute up in Canada, 229. Little larger one, Clyde River, which is also in the Canadian archipelago. Alert has a permanent population of 0, but it is a military station. And then there are some bigger ones. Dead Horse in Alaska, only permanent population of 40, but because of Prudhoe Bay being in the area, it can be up to 3,000 people at times. Barrow, over 4,000 people. Tixie, Russia, used to have over 11,000 people. Now it's down to about 5,000. And Murmansk, over 300,000. Murmansk, of course, is in the area where the sea ice doesn't extend in the wintertime near the Barents Sea. So that's why it's a port town. And also what lives up there, wildlife. Musk oxen. This is again on Ellesmere Island at Eureka. Arctic hares, the herds of them. Lemmings, Arctic foxes, wolves. And they're very curious. These are tracks around one of the Eureka Tower. And we'd gone in for lunch, came back, and full of tracks. And, of course, polar bears, and especially on the sea ice. That's where they are king, and that's their hunting grounds. When we go out on the sea ice, we were told bears are out there for one reason, find food, and you are food. So that is a problem for doing research on the sea ice.